Good afternoon. We're here into our second to last section of this unit. We're actually going to look at this idea of what we call a limiting reactant. Now, when you think of the term limiting, like a speed limit, that's the highest speed that you're supposed to travel. Some of you who drive, I've heard and seen a few things that make me a little afraid of that, but we're going to go ahead and start with this idea of the limiting reactant. Now, if you're looking at part number 3 or score 3 and saying, wow, all I have to do is be able to identify it, I just want you to know it does come with a little bit of math. Now, what you're going to do is, well, we'll talk about that in a second. What I want you to do now is I want you to go ahead and rate yourself. Where are you? Do you already understand how to find the limiting reactant? Or can you at least explain a little bit of how we might get there? Or you might be at level 1 saying, I have no idea what a limiting reactant is, or where even to start with this. So what I want you to do is take a moment, rank yourself, and we're going to go ahead and get started. Now, if you have 37 bicycle tires and 20 frames, how many bikes can you make? Well, based on what we know, each bike needs 2 tires and 1 frame. So let's see, how many bikes can I actually make? Or the better question is, which will I run out of first? Will I run out of bicycle tires? Or will I run out of frames first? Well, 37 divided by 2 gives me 18.5. So close. So that means out of this, I'll actually be able to make 18 bikes. Now, what about that 0.5 that was there? Well, knowing that bicycles run on 2 tires, and I'm not skilled, and if I have a frame for 2 tires, I have not gotten the skill, nor can I sell a bike that has only 1 tire. So that means in this case, my bicycle tires is going to be my limiting reactant, or the one that limits the amount of product that I'm going to be able to make. Well, the limiting reactant is just the reactant that you run out of first. The excess is the one that's left over. So in this case, I had more frames than I had tires to make bikes. So my frames would actually be my excess. The limiting reactant determines how much product you'll make. Now, looking at the example of what we have here, I have octane, which is C8H18, combining with oxygen to form carbon dioxide and water. This is a similar thing as to what happens in a car engine. Now, if I have these in the wrong, what's the word I'm looking, proportions, I can end up with problems. The optimal setting is going to be the 10 grams of octane to 35 grams of oxygen. This fits within the range of my reactants and forming the products as I want. If I have too much oxygen, the engine is actually going to stall. I'm not going to have enough to sort of balance it out. So I'll end up with issues with the car stalling. If I have too little, then I'm going to end up with what we call dirty exhaust, or that black stuff coming out of the car. My engine won't run well either. There's an optimum situation that I want, and that's going to be here in this center section. Now, with my reactants, or sorry, my reaction in terms, I need to be able to figure out what that optimum is. If I know how much of this certain reactant I'm using to make a certain product, I want to know what's going to give me the best return on my money. So, how do I find out which one is limited? Well, the chemical that makes the least amount of product is the limiting reactant. How will I know which one makes the least amount of product? This is where that math comes in. If you can recognize the limiting reactant problems, you'll be a couple steps ahead of the game. Usually you'll know this because they give you 2 amounts or 2 quantities in the equation. What do I mean? Well, 2 stoichiometry problems, one of them will give you the reactant. Let's look at the example we have here. If 10.6 grams of copper reacts with 3.83 grams of sulfur, how many grams of the product, copper 1 sulfide, will be formed? Now, note that I said you have 2 different quantities of the substances. That means we have to do two different tables. Now, in each of these cases, we're going to compare them to the same product. So notice that each time we're still looking at the copper 1 sulfide, how much copper 1 sulfide will be made. Okay? So 10.6 grams of copper, and I set up my conversion factor, 1 mole over 63.55. That again is my molar mass conversion. Then I need my mole ratio. It's going to be 2 moles of copper to 1 mole of copper 1 sulfide. So that means my 1 mole at the top, 2 moles at the bottom, and then the molar mass of copper 1 sulfide at the top for my final step. This gives me a final mass of 13.3 grams of copper sulfide, copper 1 sulfide. Now, for my next one, I have to do another table, but now it's going to focus on my 3.83 grams of sulfur. 1 mole converted to grams, converted from 2 moles, sorry. 1-to-1 ratio, and then the molar mass of copper 1 sulfide. Now, if you take a look here, from this point in the equation, and including this last step, you notice that it's exactly the same from here to here. So once you've done the work once, it actually becomes much easier for you because you get a chance to copy your own work. Okay? Now, after doing this, I end up with 19.0 grams of copper 1 sulfide. The question is, how much of my product will actually be formed? Well, considering these two things are mixed together, this means that the most I'll actually be able to make is 13.3 grams of copper 1 sulfide. Okay? Now, this tells me that my copper is actually my limiting reactant. I want you to understand something. Just because the value is larger or smaller does not tell you which one is actually going to be your limiting reactant. It's actually going to be more coming down, it's going to come more down to, your mole ratio that you have in there. It takes 2 times more copper to go in to form this copper 1 sulfide. And so we're going to end up with less of the product being formed based on that one. Now, notice how the question was phrased. How many grams of the product, copper 1 sulfide, will be formed? This can be asked in many different ways, so you want to be prepared for it. Okay? Now, another example. If 10.3 grams of aluminum are reacted with 51.7 grams of copper sulfate, copper 2 sulfate, how much copper will be formed or produced? Balanced equation. Starting us off, 2 moles of aluminum, 3 moles of copper sulfate, producing this. Sorry, let's get taking a look at what we have. Making our 2 tables. 10.3 grams aluminum, 1 mole aluminum has a mass of 26.98 grams. Mole ratio, 2 moles of aluminum, and we're focused on copper sulfate, which according to the equation, 3 moles. Oops, sorry. Actually, I gotta go back a step. I made a mistake. I almost made a mistake there. Again, the goal is how much copper will be produced. So, 3 moles of copper will be produced, and 1 mole of copper has a mass of 63.55. And set up a table for the second part. 51.7 grams CuSO4. Finding the information from our math, 1 mole of CuSO4. Finding the molar mass in grams. We have 63.55 plus 32.07 plus, let's see, 4 times 16, that gives us 64. 159.62. 9.62. Molar ratio, 3 moles of copper to 3 moles of copper sulfate. Oops, extend it down. And again, matching up this last part, 63.55 over 1 mole. See you. Now, after pulling this in, you have your calculator there. You can go ahead and punch it up. But 10.3 divided by 26.98 times 3 divided by 2 times 63.55 gives me 36.39 grams copper. And the bottom example, 51.7 divided by 159.62, times 3 divided by 3 is equal to 1. So times 63.55, and I get 20.58 grams of copper. So this being the case, this lets me know that the one that produced the least amount of product for me in this case was copper sulfate. My copper sulfate is limited, as was posted right here. Okay, now this is the basic idea that we're gonna move forward with for limiting reactant. Yes, you have to do both problems. I understand it's a lot of work, but you get a chance to copy a little bit of your own work to make things move a little bit quicker. Now, there's another question that can be asked here, and let me clear this for you so you can actually see. How much excess reactant will remain? Well, that's a whole nother story of what we got to go through. Now, the way that we can find this out is we kind of have to do a third table. Now, all the problems that we do will not be based like this, so don't freak out too much. But since I already know that my copper sulfate is the one that's limited, that means I need to do another table to figure out how much of my excess was actually used. Well, I know that I've already made 20.58 or 20.6 grams of copper. I need to compare that to my excess. Well, if copper sulfate was my limiting, that means aluminum was my excess. Well, 63.55, just copying the work that I've already done, 1 mole, and according to my equation, 3 moles of copper to 2 moles aluminum, and 26.98, so 1 mole aluminum. Now, this calculation that I have here on the screen will tell me how much of my excess was used. So this isn't the final answer, this is how much was used. So 20.58 divided by 63.55 times 2 divided by 3 times 26.98. And this gives me that I've used 5.82 grams of aluminum used. So how do I find out how much is left over? Well, I started off with 10.3 grams of aluminum. So I'm just going to go 10.3 minus 5.82. Come out with approximately 4.48 grams left over. Now, note, I didn't have to recalculate too many things. All it was taking the same information that I had in the previous steps and now moving them and sort of rearranging them to find out how much of my excess reactant was going to be used. Now, take a moment. Let me clear the slide for you again. Now, if you need to pause it here, go ahead and do so. Now, this is where we're actually going to end our part of the limiting reactant section. Take your time, look back over it, write down any questions you have, anything that still doesn't make sense. Where have you moved to in this statement? I mean, in this unit? Have you moved up to a 3.0? Have you moved maybe to a 2.0 or maybe a 2.5? You can explain a little bit of maybe how to do it, but you still need a little bit of practice with that. That's not a problem. My hope is that we moved you from that level 1, from that basic understanding of what is a limiting reactant, to moving into how we can use that information, which is going to come up a little bit more in the next section when we find percent yield. Write down any questions you have. I can't wait to see you in class and answer those for you. Have a good evening.